I would like to talk about the calculation of mortgage in Canada and North America in general. Home loans, people take home loans and they wonder how the monthly payment is being calculated. There are many online calculators, but it's important that we are able to, write some of this thing on paper to be able to understand the derivation of the formula that has been developed in the calculator, and also to be able to have a kind of first-hand principle understanding of some of this computation. So I've taken my time to derive the formula. I'm going to explain the formula of the mortgage calculator, and also I'm going to write a Python script just to automate the formula to compute the amount that will be paid monthly, which is a kind of annuity or a kind of amortization payment over a period of time. So it's important that we understand this so that we can see the dependence on the frequency of payments on the amount we pay monthly, or the rates also on the amount we paid. A number of parameters we can adjust, but the highlight of this presentation is about the derivation of the formula itself. We can see how the amount we paid is derived. That's the highlight. So I would just like to this is the formula. You see M here in this case is the constant payment per period, and P is the principal. This is the amount we borrow in the bank, the principal. And then R is the rate. It's an annual rate, but because you'll be paying monthly, so you divide the amount per annum by 12 so that you have the monthly rate. So this is the formula, that is P R in parentheses 1 plus R raised to power n, and then divided by 1 plus R raised to power n minus 1. So we are going to see how we derive this formula. R is the periodic interest, in this case monthly, number of payments. Every month we are going to be paying certain amounts. Okay, so this is the formula, that is a fully amortization loan cash flow to the lender are a level of annuity of M for N period. It's an amortization. That is, you are paying a fixed amount over a period of time, cumulatively, to repay back the principal that was borrowed from the lender. It could be a bank, it could be any of the lenders. So this is the formula. That is, we are looking at the amortization of the present value of the principal that we loan. So I'd like to bring up a sheet just to explain it more properly. So we are looking at this now on this sheet here. So we've got this equation where we say the principal, this is the equation 1 that we want to derive. So let's start from here. You take a principal, and then this is the future amount of this principal. That is P times 1 plus R raised to power 1 will be the future amount you will pay in N months. For simplicity, let's take this to be number of times at the end of each month, and let R be the monthly rate, that is the annual rate divided by 12. Let's simplify it that way. So then if you multiply this, P times 1 plus R will give you M. So that is what will come here. That is, if you are paying once, this will be the formula that will apply. So this once is a simplification of this. But now, if you want to pay twice, this is the first payment. The future value of this principal is M, the first term here, and then the second term here is M divided by 1 plus R raised to power 2. So this means if you want to pay twice, you have to pay the future value of the principal plus, that's at the first payment, the first month, plus the future value of the principal at the second month. So we need a fixed amount you can pay for those 2 periods of time. Yeah. So that is, we want a fixed amount you can split over 2 periods of time, such that for the first period, you are taking like approximately future valuation of the principal. And then for the second period, the future valuation of the half of the principal with respect to the rate. So this is 2. Now, if you want to pay it thrice, the same thing applies. You are looking for a certain M such that you pay it 3 times instrumentally. For the first one, it's going to be a future value of a fraction of the principal at the first month. The second term is going to be a future value of the principal at the second month. And the third value is going to be a future value of a portion of the principal at the third month. So that is the problem we want to solve. What is that future value M? Such that at equal intervals, when we add them together, we can get the principal P. So that's the problem. So we can generalize 1, 2, 3 to this n times, which is the n times here. That is, we want to sum up the future value of amortization, instrumental payments of the principal at various time t. So we want to sum up those amortized value over n period of time. So you can see that the sum here ranges from t is equals to 1, in this case the first month, up to the n month. So for a period of 30 years, that would be like 30 times 12, which will be 360 months. That is, you want to amortize each month over a period of 360 times to repay back the principal P. So what is that N that you can be paying every month? That when accumulated over 360 months, it can be equals to P. So that is the problem we want to solve. So this is the mathematical formulation of that problem. Now let's look at this equation 2. So we are trying to simplify this equation, the n times equation, by just factoring out the m and then express this in form of a power like this. Instead of 1 divided by this, it's going to be 1 plus r raised to power minus t. Mathematically, it's the same thing. And then we now want to find, so the sum this is a finite sum in this case, because we are saying from t is equals to 1 to n is a finite geometric series. And that means we can say for this now, in geometric series, it can be finite, it can be infinite. So this is a finite geometric series. That is, we know the upper bounds, and you are going to stop at a point in time. That is when you stop paying the mortgage. So now this equation 2, we can re-express it by factoring out, by assigning 1 plus r raised to power minus 1, we can say is equals to q here. So if you are saying 1 plus r raised to power minus 1 is equals to q, then we can then rewrite equation 2 in this form of equation 3 here. That is sigma from t equals to 1 to n of q raised to power t, where q is equals to 1 plus r raised to power minus 1. So this equation 3 is the same thing as equation 2. And based on finite series of this formulation, the end summation of this will be equals to this term mathematically. That is, when you sum up for q raised to power t, for t that ranges from 1 to n, will sum to this sum in infinity. Q equals to q in parentheses 1 minus q raised to power n, close parentheses, divided by 1 minus q. And then we can then, evaluate or simplify this equation on this side of the equation, this term on this side of the equation. We can expand it, and then we can say substitute q for 1 plus r raised to power minus 1. We are going to get this term. That is 1, wherever you see q here, just put 1 plus r raised to power minus 1 there. So that will give us this right-hand side term of this equation 3. So you're going to get this. So you can see it's a bit lengthy, but it's the same thing as this on this side. So this equation 2 can be rewritten as this, which we have already stated here. That is, instead of writing all of this, just substitute q for that, and then just put m here. So the equation 2 is the same thing as this, which is equation 3. Now from this equation 3, we can multiply both the numerator and the denominator by 1 plus r. So because we want to simplify this equation. So if you multiply the numerator and the denominator by 1 plus r, the 1 plus r will cancel out this 1 plus r raised to power minus 1. So that is equation 4. And then 1 plus r raised to power 1 will multiply the denominator here. So you can see that there. So this equation 4 then can be simplified further because this will cancel this and then this will expand this. So that will give us, this will give us r on this denominator, and this numerator will give us 1 minus 1 plus r raised to power minus n, because these will cancel these out and these will result in 1 plus r minus 1, which is equals to r. So that's equation 5. So this is the derivation of the mortgage formula, which is the formula that are scripted behind the calculator you guys often use on the laptop. So just, it's very interesting that you understand the derivation of the formula so that you can know if the formula you are using is accurate or the calculator is not accurate. Sometimes you might need to, enter this number on your spreadsheet, on your calculator yourself, and just make sure that you understand, the behind the scene of some of this calculator we are using. Even the bank, sometimes you can correct the bank. That's the benefit of this. Okay, let's proceed. So from equation 5, we can further simplify this because we don't want this term here. We don't want 1 plus r raised to power minus n. And that means this fraction, we can further multiply the numerator and the denominator by 1 plus r raised to power n. So if you do that, we are going to get this term, equation 6. That is 1 minus 1 plus r raised to power n, just like we have in equation 5, times 1 plus r raised to power n divided by this term. So from equation 6, we can then obtain equation 7, because this time this will give us, this will multiply this, so you're going to have this term, and this time this will give us 1, and then this time this is going to give us that. So from 7, we can make m subject of the formula here, and then we are going to have m is equals to p multiplied by this divided by that. So that's how we have this. So this is the formula. That is, given the principal at the beginning of the time the loan was taken, and you know the monthly rates, and then you know the number of times a month that you want to repay back the loan. What is that fixed amount you'll be paying monthly, such that over that period of n times, you're going to completely pay the whole loan. This is the formula you need. P times r, in parentheses, 1 plus r raised to power n, everything divided by 1 plus r raised to power n minus 1. So that's it, which is equation 8. So P here is the principal amount you borrow. The R is the periodic interest rate. In this case, the annual rate divided by 12. If you are given 5%, it shall be 0.05, which is 5%, divided by 12. So that will give you the monthly rate. And then N is the number of payments in months in this case. So if you're going to pay for a period of 5 years, that will be like 5 times 12, that will be 60 months. And then M is the constant payments per period. That is the amount you are going to be paying the bank, you're going to pay the lender every month. So this is the formula. So having known this formula now, I will bring up a script, a Python automation or a Python scripting of this, such that we enter some numbers and then we see the amount we are going to pay monthly. So I'm going to show us that now. Let me just bring the screen here. So right here, so here's the scripting. I just wrote this in Python. So you can see this is a kind of input. It allows you to enter the number, that's the number of payments. If you want to pay at the end of 5 years, that will be 5 times 12. So 60 will be the number of times. If you want to pay at the end of 1 year, that will be 1 times 12. So you need to know the number of months that you want to use to repay back the principal. So in this case, let's assume hypothetically a principal of 500,000 Canadian dollars. I'm in Canada here, maybe 500,000 US dollar, wherever you are. And then this is just a function to compute that. So this function will take 3 arguments, so the number of payments. So this number of payments will be coming from what we shall enter when I run this program. And then the interest rate, I just put an hypothetical value here, 3.98%. So it could be 5%, it could be any amount, but let's just leave this here. And then the principal is 500,000 here. So let's just take this value, but then we want to use the number of payment times as a variable, just to see how that will impact on the amount you have to pay monthly. How the M depends on the N for now. A kind of simple scenario. So when we compute that, we're going to get the M monthly. So the monthly payment times the total number of payments will give us the total payment we have to pay. So if you are paying, let's assume 2,000 for 60 months, which is 5 years. So the total payment will be each month times the total number of months. That will give you the total payment. So when you know the total payment, we take out the principal. That will be the profits to the lender. So this script will allow us to compute the amount we are going to pay monthly, and also the total payments at the end of the payment period, and also the profits, which is the total payment minus the principal. That will give us the profits. So I'm going to run the code now, but before I do that, let me just show you the function here, which is home loan calculator. So you can see it here. It's taking 3 arguments, and the interest rates and the principal. So you can see the interest rate here, we are dividing by 12 because it's a monthly rate, and then we divide by 100 because it's a percentage. So this will give us the R. Now the numerator in the formula I showed you the other time. Let me bring up the formula again here. So you can see this formula here, P times R in parentheses 1 plus R raised to power N. So that formula here is what we script here, principal times R times 1 plus R, everything raised to power N. And then the denominator, as in the formula that we derived, is 1 plus R raised to power N minus 1. So the denominator now is 1 plus R raised to power N minus 1. So this is the numerator, this is denominator. So we divide the numerator by the denominator here to get the M. So this function will return the M. So this M will then come here. So this is the M here returned as a result, or the output variable is as the output value is assigned to the variable M. And then we multiply this M, the value, by the number of payments, which is a value we are going to enter through the console of the shell of this Python interpreter workstation. And then when we know the total payment, we are going to assign the product of these two variables onto a variable called the total payment. So the total payment would then be, we can then take the principal away from the total payment so as to get the profits, as in line 60. And from there, we can then create these objects in Python where we set the principal, we set the monthly payment, we set the total payments, and then we set the profits here so that we can then print that to the console. So I'm going to run this script now. So just look at the formula again. That is, I'm going to pass the N for this rate and then for this amount, 500,000. So, but I'm going to vary the M, the N rather, which is the number of times. So let me just clear this place. So here it is now. So I'm just going to run the script here. So you can see, enter the number of payments. For example, let's say 5 years in this case. Let's start with 1 year. So I'm going to enter 12 months because that is 1 year. I will enter 12. And then you see, so it's giving me that the principal is 500,000 Canadian dollars. The monthly payment will have to be 42,570. And the total payment shall be 510,844 with some cents, dollars. And then the profit to the lender is 10,844. That is, if I decide to pay this entire $500,000 within a year. So you can see the profits and then you can see the total payments. But let's assume I want to pay this in 2 years now. Let's say 24 months in this case. And then you can see for the same principal, instead of 42, I'm going to be paying 21,708 monthly for 24 months. And then the total payment you see is risen, is gone to like 520,992, and then the profit is 20,992. So the longer you pay, the more the total payment you pay, the higher the profit to the lender. Okay, let's say for 5 years now, let's say 60. And then you can see for the same capital, the monthly repayment has reduced. So it used to be 42,570, and then 21,708, and now it is 9,230 monthly, because you're going to pay for 60 months, which is 5 years. And then the total payment has also increased a bit. It was $520,992, but now it's $552,224. And then you can see the profit has also increased, relatively. So let's assume, realistic scenarios that you want to pay this amount over a period of 30 years. So 30 years will be 30 times 12, which is 360 months. So for 360 months now, let's enter it, 360 months. So you can see for $500,000 home loan, the principal, the monthly repayments at the interest rates of 3.98 will be $2,381.31. And then the total payment at the end of the 30 years period will be $857,273.38. And then the profit will be $357,273, 3.83 cents. So the longer the payment period, the lower the monthly payment, and then the higher the total payment, and also the higher the profits to the lender. So this is the formula for calculating the repayment plan. And I hope this helps and enlightens everyone who is curious about how is this home loan calculated, how is my monthly repayment calculated. So I've shown you the formula. I've shown you how the formula was derived. It's all about amortization, and you split out the payment over a period of time. And I've also scripted the formula so that you can see how those calculators you use online or wherever, or even the bank, how they obtain the value. Because sometimes they don't give us a low level first time principle or formula. They just you just trust them, you just believe them. So you have this tool now which you can check. So thank you for watching this video. Bye. Cheers.